So here's an example. It's the same example that's in the typed slides. Let's suppose that I want to talk about a case with, for sake of argument, say 3 parts, 3 operators, and 2 observations, 2 measurements per cell. So let's talk about this kind of a case, and for sake of argument, let's imagine that what I have for some summary statistics for part 1, 2, and 3, operator 1, 2, and 3 turn out to look like this. Suppose I get a Y bar up here that is 0.3473, and I get a range up here that is 0. Suppose I get a Y bar in this cell that is 0.3466 with a range that is 0.0002. In this cell I get a Y bar that is 0.34715 with a range that is 0.0001. And if I then look across that row at the Y bars and ask myself, what do I have for a range in those Y bars? The largest minus the smallest is 0.0007. Across the second row, let's suppose that I get a Y bar 2,1 that is 0.3471 with a range that is 0. In this second cell I get a Y bar that is 0.34645 with a range that is 0.0001, and in this third cell I get a Y bar that is 0.34710 and a range that is again 0. If I look across these 3 Y bars, they have a range of 0.00065. That is, the difference between the largest and the smallest is 0.00065. Finally, along the bottom row, let's imagine that I get a Y bar 3,1 that is 0.3472 with a range that is 0. In the next cell I get an average that is 0.34655 with a range that is 0.0003, and in the last cell I get an average that is 0.34710 with a range that is 0. Looking across these 3 Y bars, they have a range of 0.00065. These measurements are in inches, so the units here are inches. The ranges and the averages are in the original units. If I take the 9 ranges and I add them up and I divide by 9, what I get is 0.0007 divided by 9, which is 0.0000, that is 4078. Okay, that's the thing that I'm going to call a y-bar, and if you add up the 3 deltas and divide by 3, you get 0.00067. And those are the inputs to what I'll make for range-based estimates of these standard deviations. So how do I estimate sigma hat? Sorry, how do I estimate sigma? How do I estimate sigma repeatability? Well, based on these ranges, what I'm going to do is take that 0.00078 inches and divide it by a control chart constant. Control chart constant for samples of size 2, because I'm dividing by, I'm making ranges of the 2 observations in a given cell, and if I look up in the table, that number is 1.128, so that when all is said and done here, I've got 4 zeros, 69, and that is in inches. Okay, so an estimate of the standard deviation for repeat measurements on the same item by a fixed operator, the estimate of that standard deviation is 6.9 times 10 to the minus 5 inches. To then go ahead and make an estimate of the reproducibility standard deviation, what I want to do is look at 0.000, oops, I got 4067. That's this delta bar thing. I need to divide it by a control chart constant. The control chart constant now for quote-unquote sample size 3, because I'm making a range across 3 operators, and that number is 1.693. I want to square that, essentially take the square root after I correct it, but I have to first correct it by this 0.0000, oops, get enough zeros in there, 4069 squared. Okay, this guy is showing up down there, times 1 over m, m being the number of observations in a cell, so that's 1/2. If that had turned out to be negative, I would replace it by 0, but it's not negative. And if I do my arithmetic, then I wind up with 0.0000. Oops, sorry, I got too many zeros. I've got 3 zeros and 396. So I've got something like 0.00007, and I've got something like 0.0004. This is a case where the reproducibility variation appears to be bigger than the repeatability variation. that has the upshot that if I'm worried about consistency of measurement, I need to worry first about the fact that operators seem to be doing different things. That is, there appear to be differences in the operators in terms of their individual biases, and one needs to address that. A natural way, if I was going to talk about the overall measurement variability here and talk about sigma R and R, a natural way to estimate that is to take these two estimated components here, square them, add them up, and then take the square root. And if one does that, basically this part doesn't really count, and I get back to pretty much just the reproducibility standard deviation.